We are starting a new topic here today. So the topics are recurrence and financial math. It's actually a combination of two different topics. So in your textbook, it's your chapter 4, financial math, and your chapter 8, number patterns and recursion. Okay, so first, financial math is dealing with money, and we explained about percentage earlier in term one, and we in financial math we're going to keep using the concept from the percentage over there, and a bit of new stuff that we learned from recurrence. In financial math, you are mainly dealing with simple interest and compounded interest, and I'll explain that later when we comes to that. Um, Recurrence or number pattern is a pattern that we can see from a sequence of numbers. And unlike what we've done in perhaps lower year levels, just fill out the gaps with the next numbers in the sequence. In here, we need to actually come up with a equation to actually describe the sequence over here. And it's kind of related to our linear equation there, or perhaps a non-linear one in some cases. But, so this will be a good practice before you go into the linear equation chapter over there. And so we are going to start now. First, we are going to start with language of sequence. This is quite straightforward. The language of sequence is just if we have our first term, then we're going to call it T1. Our next term after that is going to call it T2. Our third term is going to be T3 and so on. So my nth term over there, if you look at the last Tn over there, it's representing the nth term of the sequence that I have. So we're going to write it as Tn. Okay, so let's look at our language of sequence over here. So what we have over here is that I have an input. Our input over here is normally n, which is my number of terms. Number of terms, like my first term, second term, and my nth term, all the way to my nth term. So this is my number of term over here. Let's say if I have my n is equals to 1, so I'm going to substitute the value of 1 into the function. So a function is equation with variable. Function is equation with variable. For example, here my function can be written as t is equal to 2 times n. So I'm going to put the 1 all the way into the n value over here, and my output is going to be a term value, so it's my t value. My t, if I substitute n equals to 1 into the equation, then my t is equal to 2 times 1, which is equal to 2. So my term value is going to be 2. And because this is my first term, so I'm going to write my t1 equals 2. So for my second term, if my n is equals to 2 over here, my function is still t equals to 2 times n, then my t2 value is going to be 2 times 2, because now my n is equal to 2. So it's going to be equal to 2 and 2, and my t2, my second term value is equal to 4. And wait, I'm not very good at this yet, so spare me with a moment. So we have introduced the mathematical language that we use to describe our sequence. So that's the mathematical language that we use to describe all sequence, but there are two types of sequence that we're going to learn in this topic. First one is this arithmetic sequence, and the next one is going to be geometric sequence. Now, because they have different, because they are different, so we are going to use different terms to distinguish them. Because there are some of the unique features that they don't share with each one another. So in an arithmetic sequence, the first term, which is T1, is normally referred as A, and the common difference is referred as D. So the common difference is the difference between the first and the second term and the second and the third term. So there's a difference over there. So when we call it the common difference, and they normally equal to each other. How we find out the difference is not just term 1 minus term 2. It's actually term 2 take away from take term 2 minus term 1. So that's term 1 take away from term 2. So that's how we calculate a difference in math. If the common sequence D is positive, so the common difference D is positive, that means my T2 minus T1 is positive. Then it means that my sequence is increasing. And if my D value is negative, my T2 minus T3 value is negative, then the sequence is decreasing. Alright, let's look at this work example over here. It says determine which of the following sequences are arithmetic sequence, and for those sequences which are arithmetic sequence, state the value of A and B. And first, how do we know they are arithmetic sequence? Is they will have a common difference. Common difference. Difference. And it's noted as D. So if the common difference over here are the same, or if the difference between consecutive terms are the same, it means the difference between T2 and T1 and T2 and T3. So I'll write it as T3 and T2. So you know that how do we find the difference is the larger term take away smaller term. So T2 minus T1, T3 minus T2, and also T4, T3, and all the way to our last term is written as Tn, and our second last term it will be Tn minus 1. Okay, so all the way to there. So if the difference between these terms are the same, then we have a common difference, and it's going to be our arithmetic sequence. First, let's look at A. The first term is 2, and I ask us to state the value of A and D as well. We know that A is our first term, so my A value over here is equal to 2. And I'm going to check what is my D value. D value, first let's say T2 minus T1. So 5 take away 2, that's 3. 8 take away 5, that's 3. 3, 3. So I can safely say that my D is equal to 3 and my A is equal to 2. Because it has a common difference over here, so A is going to be my arithmetic sequence. Now let's move on to B. So B, we have for A, our first term, which is T1 is equal to 4. And my D is going to be minus 1, minus 4, minus 1, oh, minus 1, minus 4, that's minus 5 over here. And then the next one is going to be minus 6, minus 1. So when we do minus 6, minus 1 over here, we want to get rid of the bracket. And because it's negative and negative, so we're going to change that to positive over here. So it's going to be minus 6 plus 1. And the answer is minus 5. And let's keep checking that. So normally when you do it, you only need to check two terms. So you're only going to check term 2 take away term 1 and term 3 take away term 2. Okay, so normally that will call you if you can see a common difference over here. But for safety consideration or for computation practice purpose, I'm just going to show you a few more. So I have minus 11 over here, minus make it positive. So positive 6, minus 11 plus 6 minus 5. and then I have minus 16 minus negative 11 over here, and that's equals to minus 16 plus 11, so that's minus 5. And minus 5 equals to minus 5 equals to minus 5 and equals to minus 5. So my D here, which is a common difference, is equals to negative 5. So this is also an arithmetic sequence. Now my C. So when you're doing sitting for exam, you're not just going to do a tick over here. You're going to write out because they have a common difference, and the common difference is value is 3. The common difference value is 5. So this sequence is an arithmetic sequence. So you need to make sure that you have answered the questions, and you have in your answer or in your conclusion you may want to mention your value of a as well. Okay. Um, all right, now let's keep doing my third one. The first term is 3, so a is equals 3. Oh, why I'm writing on here? Okay. A is equals to, let me see, pointer option. Yeah, eraser, pointer option, pen. Okay, so my a is equals to 3 over here. Then my D, let's check my term 2 take away term 1, which is 5 take away 3 is equal to 2. And my term 3 take away term 2, T3 take away T2, T3 is equals to 9. 9 minus 5, that's 4. So I only checked 2 terms over here, but I already noticed that the difference is not the same. So we don't have a common difference over here. So I can't write the over here. So because the difference are different between the consecutive terms, so I can say that this is not an arithmetic sequence. Remember earlier we said that we have input. Where's my pointer again? Oh, here. Where we have an input, and we have put the input into the function, and then we will have an output. So far we only study on the output, which is the t value over here. We made a little prediction on the, we can make a deep little prediction on the t value or that we haven't. So what we have done is try to start the pattern that between the t value over here. And also if we look at these input function and output, this is normally what we have in computer coding. So if you guys are interested in IT, then you might find this quite familiar. But also you should know that, as I say, this is going to be related to your linear equation. So in your linear equation or in your science, you will also have your input or output. Your input over here is normally an independent variable. Independent variable. um, such as your n. So your n value is always 1, 2, 3, 4, 5, and all the way to whatever you want it to be. So it's not dependent on any value over there. So that's what we call your independent value. And normally in linear equation, we will have that represented by x. But this case, we are going to represent it by n. It doesn't really matter what variable that we call it as, because um, it's just a name for the variable. So like say you call me Miss San, and I don't mind you to call me Yajun as well. So that's just a name, and so the nature of that is independent. It's not going to be changing. And our output over here is going to be my key value for my sequence. But if we have a linear equation, then it's going to be represented by y, because the y value is dependent on my input. It's dependent on my x value over here. Okay, so like the washing machine, it's what kind of clothes you have is the cleanness of your clothes is depends your detergents that is being used. So that's what we call an output variable or an input variable here. Oh, okay. And this is your, so if x is your independent variable, then your y is going to be dependent. I've been spelling it wrong all the time. Um, it's very hard to write and speak at the same time, and because I can't see what I'm writing on the screen, so it makes it a lot harder. Okay, just ignore my spelling or whatever mistakes, but I think it doesn't really affect your understanding. So what we have over here is it says that we can generalize any arithmetic sequence to be an equation represented by these. So we are not going to look at this for a second. I'm just going to use the previous example that we done, and then we're going to see if we can come up with this equation by ourselves. So what we have over here is the function that we are looking for. So if you try to generalize our sequence by writing up t n, a, and d over here. So a is our first term, which is t1. D is the common difference between consecutive terms. Common difference, and my n is my variable over here. So if you can see, I only have two variables, so only my n and my t value is changing. My t1 and my d value is always the same. So um, even if my a and d are written up in not in alphabet over here, but what we can do is treat it as constant. So constant is something that's not changing, like a number. So but because for different sequence, my a value and my d value, so my first term, the value of my first term, and the value of my common difference will not be the same. So that's why when we try to generalize it, we have that representing as a and d. But in the same sequence, my a value and my d value are not going to be changed. So I'm just going to use the previous work example that we've done as an example over here. So I have my n value. My n value is going to be 1, 2, 3, 4, 5. So my nth term, first term, second term, third term, fourth term, and fifth term over here. And I have my t value to be 2, 5, 8, 11, and 14. Okay, so this is A of my R. This is a really bad grid that I'm drawing over here. Okay, all right, and see an angle as well. Okay, anyway, um, because my first term over here is equal to 2, so I can say that my A is equals to 2. Okay, and how do I get my 5 over here? Is my T1 plus the common difference. We just say that our common difference in this case is equals 3, right? So how do I get that? Is my first term plus the common difference. Okay, and how do I get my number 8 over here? Is my second term plus my common difference. But what can my second term be written as? My second term is equal to my first term plus common difference. So I can write this as my first term plus common difference. So that's my second term over here plus common difference. Okay, so my fourth term is my term T3 plus common difference, right? So that's 8 plus 3. So my term 3 can be written as term 1 plus term d plus d plus 1 plus d plus d. So this is my third term over here, and um, plus another d. So that's my fourth term. Okay, so now I want you to pause the video and try to work out your fifth term and see you can do that. Okay, so like my previous one, my fifth term is equals to my fourth term plus d. And my fourth term can be written as t1 plus d plus d plus d. So that's my fourth term, t4 over here. and T5 is T4 plus D, so I need to plus another. So what I have is T1 plus 2D, sorry, plus 2D, and this is my T1 plus 3D, and this is my T1 plus 4D. Now I still have a number that's keep changing all the time over here. So I'm going to have that represented by something that can describe in our mathematical language of sequence. So if I look at the two and compare the number that compares the number of term over here. So this is 2 and this is 3, this is 4, this is 3, this is 5, this is 4. So what we have is the coefficient before the d value is always one number smaller than the n number over here. And in fact, we have t plus d over here. So that's actually 1d. Oh, I'm doing yeah, I'm not losing it. Okay, so that's actually t1 plus 1d. Okay, and my first term is actually my t1 plus 0d. So see that coefficient in front of d, it's always one less from n. So to generalize that, we can read that as t1 plus n take away 1d. Okay. Now, because in arithmetic sequence, we turn to represent T1 as A. So because sometimes the sequence do not start with the first term, it can start with the second term. So it doesn't matter which term that we are starting with, A is always the starting term. Okay, so A could be equals to T2, depends on which part of the sequence that you're screenshotted. So instead we can have my Tn is equals to A plus n minus 1d. Okay, so my Tn is equals to A plus n minus 1d. And let's check back to the equation over here. It's same as what we have. So we just prove that equation by ourselves. And hooray to everyone. Well done. Okay, so let's look at this work example. It says determine the equations that represent the following arithmetic sequence. Um, the equation that we have derived is in the previous slide, but we're just going to keep practicing and see if we can come up with the equation by ourselves again. Oh, okay, so my line drawing skill has not been improving from the last time. So still I'm going to put my n over here and my t value over here. And I'm going to write it as probably write it as tn. The first term, second term, third term, fourth term, and fifth term. T is 3, 6, 9, 12, 15. Okay, and my tn one tn, so that is 3, so that is t1, or that is a plus 0d, and that is so my t1 plus 3 over here, so my d value is equal to 3 in this case. T is equal to 3, and that is my a value plus 1d, and that is my t2 value, t2 plus 3. My t2 is t1 plus 3, which is a plus d, and 3 is d, so a plus d, and that is a plus 2d. My fourth term is t3 plus, I'm not going to write 3 anymore because I know my d equals 3. So I can represent any 3 value over here by my d. T3 is a plus 2d, a plus 2d plus d. So that becomes a plus 3d. And that is my T4 plus D. So that is my A plus 3D plus D. So that is A plus, sorry, A plus A plus 4D. Okay, so to generalize it, now we look at the coefficient that in front of the D value. Because in the term um I'm representing everything with something that I know. So I know A in my sequence language. I know D in my sequence language was that's representing. So I'm going to change everything to something that we use to generalize the equation. So this is just deriving the equation, but some of you may already have done that. So just by substitute the numbers of your A and D into the equation, so maybe you have already solved it. But I'm just going to derive the equation again for some of you who may not understand. So my Tn can be representing that as A plus, and my 2 is 1 less than 3. My 3 is 1 less than 4. My 4 is 1 less than 5. My 1 here is 1 less than 2, and my 0 here is 1 less than 1. So the coefficient of D is always 1 less of n. So we just need to n minus 1D. Now, because my Tn and my n are my variables, so they are the input and output of the equation. What they want to us to solve over here is the value of A and D. Now we know that our value of A is 3, so that's what we're starting with. Okay, so that's my T1 value, so it's equal to 3. And my so because I don't know my n value, n is a variable, so I'm going to keep the n over here. My d value is going equal to 3. Normally I will write the number that in front of bracket if inside the bracket have an alphabet, have an variable, so that's what we normally write that as. So the equation for question A will be Tn is equals to 3 plus 3 times the common difference times n minus 1. Okay, so let's look at B. So for B, I'm just going to substitute the values of A and D in there. So my A value is equal to 40. My D value is always the larger term take away from the smaller term. So it will be the second term take away first term, or the third term take away from the second term. And it have to be consecutive as well. So 33 minus 40, the answer is negative 7. Negative 7, yes. Yeah, negative 7. Okay, so now I find my A value and my D value over here. So what I need to do is substitute the value of D and value of A into the equation. So for that, my Tn value for D sequence over here would be 40 plus n minus 1 times negative 7. Okay, so I'm just going to tidy up the equation a little bit. That's 40 minus 7 times n minus 1. Now, because my common difference over here is a negative number, so the sequence over here is decreasing, and it is decreasing, so we got that right. Okay, here what we have is sometimes the question will ask you to find out Tn value with the equation given to you, and sometimes it's asking you to find A the some of the other variables that's been given to you. So let's say for example, if they ask you to have find out n, then they will give you the value of a and d. And if they want you to find out a, then they will tell you tn and d. And if they wanted you to find out n, then you will tell you the other unknown terms, not variables, because only t and we want to call it variables. So I'll call the others unknown terms, in this case t, n, a, and d. And if they ask you to find out d, then you need to know t, n, a, n. Okay, so if they want you to find out a, so in this time my a becomes my variable over here. So find a. So um, from the equation, I want to have something as, remember when we calculating and find out linear equation. So for linear equation, so let's say my a is my x over here. So I want to put my x on one side and all the other terms on the other side. Because if they want us to find out the a value, they will give t, n, and d. So we can treat these alphabets or these variables or these unknown terms as a constant, so as a number. So what we want to do here is also the same. So we want to put a on the on one side and all the other terms on the other side. Okay. So with a bit of tidy up. So it doesn't really matter if I want to put it on the left or I want to keep it on the right hand side. So because we can always swap around that in the end over here. The two sides of the equation are always equals to each other. So it doesn't matter if we are writing a on the left or a on the right. Now because the a for this time is on the right, so I'm just going to write um, going to keep my a on the right hand side over there. Okay, and if you are not comfortable or not happy with that, you can always swap it around in the next term. But leaving a on where it is save me one step, because when I move a to the left hand side, I need to change the sign of it. And when I because this is a positive a, when I change it to the other side, it becomes negative a. And later I need to get rid of the negative sign to make it positive. So to save all this drama, I'm just going to keep my a on the right hand side over here. Okay, so what we have is I have two terms on the right hand side. I have a and I have n minus 1, the difference between n minus 1 and um, times d. So that's one term, that's second term over here. Okay, so because there's no plus or minus sign over there, so that we treated that as one term. Okay, so I'm going to first move this term all the way to the left. So because it's plus, so to get rid of that, I need to take away n minus d times n minus 1 times d. So tn, and whatever I've done to the right hand side, I need to do the same on the left hand side as well. So tn minus n minus 1 times d. And so the positive, the plus and minus get cancelled out. So all we have is a on this hand side, on the right hand side. And if you want to shift that around, you can write that as a is equal to tn minus n minus 1 times d. Okay, so I've explained to you, you can treat it as um, plus and minus can be cancelled out, or what you can also do is you can treat it as you're moving the term to the opposite direction. So when you're moving the term to the opposite direction, you're going to change the sign. And that's why the positive becomes minus over here. And because you are moving it, so it's been moved from the right hand side to the left hand side. So there's no other terms here on the right hand side. And as you can see, the result of that are exactly the same, but it's just the thinking process is a bit different over there. So now we have reached the conclusion that A is equal to Tn minus n minus 1 times D, and it matches the equation over here. So we have got that right. Now let's try to find D. I believe you can do that by yourself, and if you think you can skip the video, and if you're not sure if you can, I want you to pause it and try to solve it out yourself. And if you have no idea how to do it, you're just going to keep watching the video, and eventually you will know how to do it, hopefully. Okay, so the equation is du Tn is equal to A plus n minus 1d. Now, because what we want to find is d, so we're going to keep d on one side and all the other terms, t, n, a, and n, we're going to treat it as a constant, so as a number. So we're going to keep all that on the other side. Yeah. Um, so what we have is we still have two terms on the right hand side, a and n minus 1 times d. So this term is the term involves d. So I'm just going to keep it on the right hand side first. So I'm going to move a to the left hand side. Okay, so now let's try moving the a instead of minus both term minus same term on the same side. So the sign in front of a is positive. So when I move it from the right hand side to the left hand side, we will change from positive to negative. So I have t and minus a. Because that term has been moved, so it's no longer there. And so all we have is the next term. The sign in front of the second term is plus or is positive. Um, I can just write n minus 1 times d over here. And now I have n minus 1 times d. So to get rid of that, or like we say, if we want to move it, we need to change it to the opposite operation. Now I say that we are changing the sign over here, but we are also changing from plus a. So if I switch these two terms around, you will have n minus 1 times d plus a. So the opposite operation of plus is minus. So that's why there's a negative sign over there. Now, we have over here is n minus 1 times d. The operation we have over here is times, and the opposite operation of times is divide. So when we move this term to the other side, we going to divide it by n minus 1. So when we are dividing it, we need to make sure that we are divide the whole left hand side by n minus 1, not just a or not just t n minus 1. Okay, so we need to make sure that we are dividing the whole left hand side by n minus 1 over here, and that is equals to d. So you can also shift that around as t is equals to tn minus a divided by n minus 1, and it matches the equation over here, so we got that right. Now the last one is n, so I will say find your n. We are still using the same equation over here, a plus n minus 1d. Okay, so still, I have two terms over here, and the second term is the term that involves n. So I'm going to move my a to the other side. That's tn minus a equals to n minus 1 times d. So n minus 1 times d. Now n minus 1 is what we want to keep on the right hand side this time, because it has an n in there. And d is what we don't like, so we want to throw it to the other side. Now the operation sign between them is times, and to move d over, we need to change time to the opposite operation, which is division. And so we're going to do tn minus a. Remember the whole term, the whole left hand side divided by d, and that is equals to n minus 1. So now we want to change, so we want to get n equals something, so we need to get rid of the minus 1. Now you can do it by +1 +1 on both sides, or you can say I'm going to move the -1 over to that side over there, so that we have Tn minus a divided by d plus 1. Okay, so remember, when you are moving the terms, when you are moving the numbers over here, it's always moved to the whole left hand side or to the whole right hand side. You are not going to write Tn minus a plus 1 divided by d in that case. Alright, because what you are adding is actually adding 1 on d. So that's not equal. That's not equal. That's wrong. Okay. So you always write it added or times it or divided by the whole left hand side. Okay. You're treated as 1. You're treat the whole left hand side as 1 term. Okay. Now the example over here. So I'm going to write my Tn is equal to a plus my n minus 1 times d, the equation over here for my reference. So first example is a find out the 15th term of the sequence 2, 8, 4, 15, 20, 26. So the 15 terms, why I'm writing d over here, a the 15 terms, what does the 15 telling us? What is the 15 representing? So the 15 is representing my n value because it's 15th term, so I know that my n is equal to 15. And it's asking the 15th term, so it's asking for T15 equals to what number? And let me refer back to the equation that we have. So what we are looking for is Tn or T15 over here, and we find that our n is equal to 15. And if we refer back to the previous slide that we have, so we have to know our value of a and our value of d as well. So a is the first term, is the starting term, a is equal to, and my d is equals to 8 minus 2, that's 6. 14 minus 8, that's 6 as well. So my common difference over there is 6. Now I have all the unknown terms that in the equation. All I need to find out is Tn. So I'm going to substitute the values in. My a is equals 2, so I can write 2 over here, plus n minus 1. N is equals to 15, so that's 15 minus 1 times d. D is equal to 6, so times d over here. That's 14 plus 6. 14 plus 6 is 84. And 2 plus 84 is 86. Okay. So B, find out the first arithmetic term. So find out A. What is A equals to? In which T22, okay, so I know my T22 is equals to 1008. And here I also know that my N is equals to 22. And my d is equals to -8. So I'm going to substitute my T22, which is Tn number, over here into the equation, my n value 22 into the equation, my d value -8 into the equation. Now you can go back to the previous slide and write it as d equals to, you can write it as d equals to Tn minus a divided by n minus 1. You can if you can find the equation in the exam and you have got that in your summary book, this is where you can go from. But I don't like this method because there's a lot of memorization. What I'm going to do is I only need to memorize one equation over here, so that's the one that I'm going to remember. So I'm just going to substitute the numbers into the equation over here. Okay, so I will have, and then I will rearrange it again. I'll have 1008 equals to A is unknown, so I put, oh, sorry, I'm looking for A, so I'm using the wrong equation over here. But I think you get what I mean. So that will be, if I'm looking for A, then I will write it as A is equals Tn minus n minus 1d. Okay, yeah. So A plus, let's keep doing it. So I'm not going to write that one, but you can do that if you want it. So I'm going to write n minus 1 and then minus 1, n is equal to 22, so that becomes 22 minus 1 times d. Now d is equal to negative 8, so make sure that you have included negative sign over there. So that becomes a plus 21 times a. 21 times negative 8, sorry, 21 times negative 8 is 168. And that equals to 1008 over here. So my a value is, so that becomes, the right hand side becomes a minus 168. So now I need to move this term to the left hand side. So the negative sign or the minus becomes plus, and that is 1176. So my a value is 1176. Of course, you can do this with your calculator as well, but because that's, well, at some point you would need to know how to calculate it by hand, and this is more pretty way of doing math, so that's why I'm showing you. And I'm pretty sure that you don't need me to show you how to do it on your calculator. Okay, so C is a find the common difference of arithmetic sequence which has first term of 12 and 11th terms of 102. 102. So what we know here is first term is A is equals to 12, which is T1 equals 12, and in that case my N is equals to 1. And that's my first term. So this is the information that I have from the first term. The next one is the 11th term. So T11 is equals to 102. And the equation says that Tn is equal to A plus n minus 1d. Oh, what I'm looking for over here is my n value. No. Oh, it's my d value. D is equals to one number over there. So I'm going to substitute my T equals 11 into the equation over here. So T11 is equals to 102 and A is equals to 12. And when that term is equals to 102, my N is equals to 11. So that's 11 minus 1 times D. Okay, so I'm just going to solve the equation now. This is the term that involves D, so I'm going to leave it alone for now. And this is the term that do not have a D, so I'm going to move it to the other side. And that is not 80, 80. Is that 80? No, it's 90. That's 90 over here. So pointer options 90 equals to 11 minus 1, that's 10, 10d. So my d here is equals to 9. Right? Solved. Now the last one. Okay, d is saying that the first term of 40, so a is equal to 40. D is equal to 12. Which term has the value of 196? So my Tn is equal to 196. It's asked me to find out and which term. So it's asking me for the value of 10 and no other. I'm going to do the same thing, put that numbers in the equations there. I'm not going to read it out because I have been doing that for many times already. And I want you to solve it by yourself as well. So I'm just going to be very quick with the calculation over here. So all right, check your answer with me. So yeah, the step is not very detailed, but if you have problem with the calculation, you can always use your calculator for that part. Okay. Right, the equation itself is pretty straightforward, but here I'm just going to use this example to explain what it means by that. So the previous slide says my n plus 1, tn plus 1 is equal to tn plus d. And we know that, so the next term, the larger term is equal to the smaller term plus the common difference. And your t1 is equal to a. Right, I think that's what you're also here. So this is what you say when they ask you to set up recurrence relation to represent the thing, to represent the sequence. So you're going to write your tn plus 1 is equal to tn, and my d value over here is minus 5 minus 9, so that is equal to 4. Yeah, 4 plus 4. You're going to write that equals 4, and your t1 is equal to a. So t1 is equal to a, t1 is equal to minus 9. Okay, so when they ask you to set up recurrence relations, you need to say, state your first term and state that your next term is equals to the previous term plus the common difference, and put your value of your common difference in there. So this slide is about arithmetic sequence application. The first one we have over here is simple interest. Before I get to the formula that's written over here, I'll first explain what is a simple interest. So the bank will encourage people to lock in their money in their saving account for a term, so then they can use this money for other investment purpose, like lending it out to other people and um, things like that. So in return, it will give you an interest. So a small amount of the money that based on your investment. So that's called the interest. So if they want you to lock in for a term, then what is called term deposit. Term deposit. For example, um, if I use the example from our Commonwealth Bank, like you can see over here under term deposit, they have some special offer that's offered me. I'm just going to explain what it means over here. So first we have 1.30% PA. PA is per annual, so that's for per year for 8 months. So that means that so in that 8 months time, your interest get paid is 1.30% per 12 months. Okay, so um because that 1.30 is for per 12 months, then when you have a similar question like that, you will show that how much that you will have for 8 months. So if I know that 1.30 is for per annual per year, that's for a period of 12 months. So how do I find out that how much interest will I have for 8 months? As do you remember our line graph over here? So that's representing 12 months. 12 months, and total of that is 1.30%. So I want to find out what 8 months is I want to find out this shaded part, which is 8. So what I'm going to do is I'm going to cut the whole into 12 different units. So 1.30% divided by 12. So that's how much the interest I'm earning per month over here. And I have a total of 8 months, so I'm going to times about 8. So that's the percentage of earning that I got from the bank for a period of 8 months with the given interest of 1.3% per annual. All right. So, but that doesn't really tell me how much of the money that I'm getting, or what is the 1.30% off. So the 1.30% is of your total money that's being invested, which is the principal over here. Okay. So let's say if I have $1,000 invested for 12 months for an interest of 1.30%. So my 12 months, so my 1,000 over here is my principal. So that's the total amount of money that I'm investing. So that's my principal over here. And 12 months is a time, so that's the investment period that I have. Okay, so that is the time. And 1.30 is the interest rate, is the R. Okay, so because I know that the 1.30 is per annual, so that's per year, and then that is for a month. That is for the unit for t here is months. So remember, before we do any multiplication, we always need to make sure that we are using the same unit. So that's months over here, and that's year over here. So of course that they don't share the same interest. So what I'm going to do is I'm going to convert the months to year. So that is 1 year here. And then if I have, so I'm going to lock in $1,000 for a year with a given interest of 1.30% per year, then the money that the interest that I'm earning will be my 1,000 times 1.30% times a year. Okay, so then I'll find out the answer is $13. So if I lock in $1,000 for a year, the amount of interest that I'm earning will be $13 over here. Okay, now what I'm going to show you is, so that was saying that I'm going to lock in the money for 12 months. So I'm going to use the 8 months example here to do that again, to show you if I have 8 months over here and my rate is 1.30% per annual, what you can do. So first we talk about that um, we need to make sure the time and the percentage or the interest rate should be used for the same unit. So that is per year, that is per month. What I can do is I can keep that per year and change that per month. Okay, so for that part is the total interest that I'm earning for 8 months. I'm just going to leave that alone for now. That I'm going to come back to this and explain what I've done over here. Okay, so but just keep in mind that what we say is the amount of interest. So that's the interest rate for 8 months. 8 months. Okay. So now coming back to what we have over here. So 1.30% of the total per annual. So that's always of the total, so total amount of money that you have invested per annual. Okay. So the new interest rate is of course I can change my 8 months to year. So because we know that there are 12 years in the month, so how much that of a year will be? So that will be 12 over here. That will be 8 over here. So if I'm going to treat the whole thing as 1, what I'm going to do is, so to get the 12 to the 1, so now original, the total is 12. Now I want to change that to 1. So what I can do over here, remember our ratio. So I want to change the 12 to 1. So I need to divide my 12 by 12 to get to the 1. And the 1 here representing one whole or 1 year. And because I divide the 12 by 12, so I'm going to do the same thing here as well. So divide the 8 by 12. And another way to think of that is, instead of treating that as a whole and treating that as a fraction, I can treat the whole thing as percentage. So I'm converting that to percentage. So part divided by whole is how many percent. So that in percentage. There will be a decimal in percentage. I'm just going to keep the fraction to make my calculation easier over here. So my interest is equals to still 1,000. My principal, because that's the interest rate of the principal. So the interest time principal, the interest rate time principal will be my actual interest value here. Okay, so that is rate of the total. So when you say of the total in the calculation, you will know that you will use that percentage, or you use that fraction, you will use that part to times the total. The of here often indicating the multiplication operation sign. So that's 1000 um, times 1.30, but because that's per annual, so that's for 1 year. That's the amount of money that I've locked in for 1 year. Now, if I want to find for 8 months, so I need to times the fraction. Because there are 12 months in a year, and what I have is 8 months over here. So I'm dividing the whole year by 12. So remember our fraction line over here also can be indicating, also means division. So I can divide the whole interest by 12 and times it by 8. So look at over here, that's exactly what we have. So if you compare these two, that's exactly what we have. So instead of dividing interest rate by 12 and times the months over here, what I've done over here is I've calculated the amount, the interest in dollars for a year, and have it times by the fraction that I'm looking for in the time period. Okay, so from that, if you calculate that, so that I'll have 13 times 8 divided by 12. I won't do the calculation, but you can do it on your calculator. So now we know how to find out the interest. So basically, the interest can be written as, so interest is equal to principal, which is the $1,000 that we have used over here. So that's the amount of money that you have invested, put into the account, term deposit account. Interest time R, so 1.30% is the rate. So interest time R times time. Okay, so the first one we use, the time we use is 1 year, so I'm going to use 1 year over here. The second one I use is also in year, but instead of 1 year, it's 8 and 12 years, so times time. So when you do the calculation, you need to make sure that your rate over here, if is that is per annual, you need to change that to change the unit of time to year, or you can change the unit of that to months first, and then you can keep your time as months. And so for some questions, you might dealing with different time units, for example, minutes, days. So make sure you have done the unit conversion over here. Now let's compare the equation that I have got over here and they have got over here. So they have divided the whole thing by 100. What they have done is they have keep the number part of the percentage sign 1.30% is equals to 1.30 divided by divided by 100. Now, because we have done a percentage, so you should be quite familiar with that. I don't want you to do this because your percentage rate is normally representing by your percentage rate is normally representing by a percentage, so there's no need to keep the number part and divide it by 100 over here. What you can do is you can just write your R in that format over here, and when you put in the number, make sure that you have included the percentage sign in there. Okay. All right, and then how do we calculate percentage sign is that because you're investing the amount of money you invested will for the most will be normally will be whole hundreds. So it will be easy just to cancel out two zeros over here and get rid of the percentage sign there. So like what I've done in these two cases. So when I'm doing my calculation, I have crossed out the last two zeros. So when I'm doing calculation, I'm just using 10 times 1.30. So that's where I got my 13 from. So in the end, also make sure that you have included units. So this is not a very good, well, um, well drawn money sign, but yeah, you get the idea. Okay. Now let's see an example. So we have $1,000 over here, simple interest, and 0.5 per month. So first, the $1,000 is the principal. So my principal is equal to $1,000, and then it's simple interest. So well, simple interest. And then the rate is 0.5 per month. So R is equal to 0.5 per month. Now the unit here is very important as we discussed the y. So I'm just going to put the unit here as well. Now question A is say set up an equation to represent this person's situation as a arithmetic sequence when TA is the amount of in Angelina's account after n months. So Tn is the amount, so that's the total amount of money. Okay, now refreshment for arithmetic sequence, what we use to describe Tn as Tn equals to A plus N minus 1D, where Tn is the term value, A is the starting term, the value of the starting term, which is T1. Okay, and my N over here is the number of terms. So if N can be 1, 2, 3, 4, all the whole numbers. And my D over here is common difference. Common difference. Okay, so what in this question is, so Tn is representing the total amount of money. A is the money that she's starting up with. N is the months. So N is the number of months, and what we need to find out is what is the common difference. Now, if we think back to our concept of simple interest, how it works is you save a amount of money, and at the end of for look and have that lock in for a period, and at the end of the period, you will be a couple of dollars rich. Okay, and if we do that again, you will be another you will be you will reach for another if you are going to repeat that cycle, then in the next month, let's say in the first month you are $5 rich, then in the second month you will be $5 richer. So compared to where you started with, you will be $10 richer. Okay, so that's what the simple interest is. So simple interest is that doesn't matter how long that you have been logged in for, the rate is not going to change. So the amount of the interest that you earn for the same amount of time frame is not going to be changed. So it doesn't make a difference if you are saving the money for a month or you're saving the money for 100 months. You're always going to earn $5 per month. Okay, of course that if you're going to have that login for 100 months, it will be $500 richer by the end of the term. But if we calculate the average amount of money that you earn, it's always $5, $5, $5, $5. Okay, so that's what simple interest is, and it's going to make a difference when we learn compound interest later in this topic. But now let's just focus on this question. So A is T1. So in the beginning of the first month, what is the amount of money I have? Now, because I'm starting with 1,000, so in the first month, so when my n is equals to 1, my Tn is actually equals to 1,000. So my A is equals to 1,000. So that is my A there. Okay. And in the second month will be $1,000 plus the interest. Like I said, in the start of the second month or in the end, by the end of first month, I'll be a couple of dollars richer because the interest that have been paid to me. how do I find out the interest? The interest is equals to PRT. P is the principal, so that's $1,000 there, and R is equals to 0.5%. So I times it at 0.5% per month, and my T value over here. Sorry, this should be big T over here, and my T value there is 1 month because the because we only save the money for a month, so that will be for 1 month times it by 1. So how do I calculate that? I get rid of the percentage sign and the two zeros over here. So that's 0.5 times 10, and that is equal to 5. So we are $5 richer by the end of first week. So the interest over here is 5 months. And like I said, the amount of interest is not going to change. Doesn't matter per, because so you're going to earn $5 per month. Okay, so it won't go. So the deal doesn't get better if you say I'm going to lock in for a few months. So you will always have the third term will be the second term plus your interest and plus another interest. So if you compare that, you can see that the common interest is my I is my the common difference is my I over here. And how do we represent it in arithmetic sequence is by D. So I know that my common difference is 5 over here. So, and let's look at back to the equation, to the question. It says set up an equation. So equation is over here representing Tn, and we use Tn and n to represent this. Now we find out our A value and D value here. So we can put in our A value and D value and set the equation. A is equal to 1,000, and my n, I'm going to keep it because that's my variable, and my D is equal to 5. So times D. All right, so question A solved. Um, Now it says use your equation from part A. This is very important information over here. It says use the equation from part A. So you have to use this equation. Now, if you can't get it right, like if you don't know how to solve it, at least in your summary book, you will have the equation as Tn equals to A plus N minus 1D. You put that over here, and you'll go give the best guess of your A value, what your A value is. Now you only have 1,000 over here, so that's what you're going to put in. If you don't know the D value, you're going to make a guess. You know there has to be a difference, so you can say times 1, okay? But because even though your n minus 1 times 1 is just equal to n minus 1, so in your answer, you're not going to just write n minus 1 over here. You're going to put the times 1, make sure that indicating to whoever's marking your paper that you put your D value as 1 in there. So when people are marking your paper, they will know that you get the A value, but you didn't get the D value correct. So you will still get part of the mark over there. Okay, and then to allow that you will and then you can use you can have consequential mark when you're doing part B there. Okay. Now okay, how do I know that this is the equation I have to write? It has Tn, it has n over here. Think back, and it has arithmetic sequence. That should give you enough clue to let you know that this is the equation you're going to copy out from your summary book. Okay, let's keep doing the question. Use your equation from the part A to determine amount of money in Jelina's account at the end of each of the first 6 months. Okay, so for 6 months, then I know my n is going to be equals to n is equal to 6, so my n is equal to 6 here. And I just need to substitute n equals 6 in the equation at the end of each first month. Okay, now because it's at the end of each 6 months, it's actually in the beginning of the 7th month. So look back to our equation over here. So at the end of the first month, my interest has already been paid. So H actually when n is equals 2. So what are we going to do here? Instead of n equals to 6, we're going to write n equals to 7. Okay, because they say at the end of each month, and your interest is always paid at the end of the month. So you need to make sure that your interest has been paid for 6 times. If you are using the interest equation, is pretty simple. You know that your interest is being paid 6 times, so what you need to do is just interest times 6, and it say the amount of money that in her account. So it's not just the interest, so I need to plus the principal as well. So that will be, because I know that my interest is equal to 5 over here, so that's 30 plus 1,000. That will be 1,030. So if you have done that in this way, you might only get 1 mark, because you even though you solve off the question, but you're not using the method that it asks you to. Okay, so make sure that you use that what it asks you to do. And if you're not sure, you always can cross check by this method over here. Now I said my n is not going to be equal to 6, it's going to equals to 7 instead. I'm going to put 7 in and check if there's a match. So the equations is 1,000 plus n minus 1 times 5. So if you copy that question, copy that done, you'll, if it is a 2 mark question, you'll get 1 mark for that. Okay, and then I'm going to put my n values in. My n is, oh, it's probably going to be a 3 marks question. So you get 1 mark for the um for the you might get 1 mark for the equation. You got 1 mark for n equals 7, and then you will get 1 mark for the final answer there. So it will be 1,000 plus 7 minus 1 is 6 times 5. And if you check that, that's exactly what I have got over here. Okay, so that's the same equation. So I'm going to know that this has to be correct, because the same equation will lead me to the same answer. Make sure that include your unit there. And so we've done for question B. Now in question B, you're going to show me your answer. You're going to say, so the amount of money in her account is going to be $1,030. And this sign over here, it's so. Okay, so and this is a mathematical terminology as well. So if I've got 2 dots at the top and 1 dot at the bottom, that is called because. Okay. Now the last part, calculate the money per month at the end of 18 months. So we can, it doesn't really say which method that we need to do. So I'm going to show you by this method, because that's easier. So at the end of 18 months means my interest have been paid for 18 times. My interest times 18 times plus the principal, because it's not asking for the amount of interest, it's asking for the amount that's in her account, so you always need to include the principal over here. So that's 5 times 18 plus 1,000. That's 90 plus 1,000 is equal to 1,090. Okay. Now also you can see, okay, this is 6 months, this is 18 months. So this, the time frame of 18 is 3 times of that. So my interest must be 3 times of that. So my interest in that 6 months is $30. So what else I can do is 30 times 3, and that's the interest for 18 months, and plus the principal. You will get the same answer. And of course, you can also do if your n is equals to 19. So at the end of the 18 months is at the start of 19th month. So you can put your 19 over there and carry out the equation. Okay, I'll say this is more easier concept. This is an easier concept, but when they ask you to show your answer in arithmetic sequence, that you don't really have an option, but you can always cross-check your answer from a different method, by a different method. Write-off value is not there's no actually any difference with the simple interest. Write-off value is your if you are holding a asset, the amount of that may be decreased because you keep using it. Let's say my Nintendo Switch, the value will be worth less after I've used it for a few months because of the condition of it. And that is what write-off value is. So instead of gaining money, you're actually losing money. And the write-off value is going to be a simple interest as well for some of the cases. Like for example, I'm probably going to lose $1 a day because of the frequency that I've been playing with that. So when we doing the calculation, there's actually no differences, but so instead of when we having an interest and we want to find out the total value after the amount of time, we use the principal plus we use the starter value plus the interest. For a rate of value, if we want to find out uh, the value that it was at the end of a time period, we're going to use the starter money minus the depression value over there. Okay, here is another example for the write-off value. Um, a new car, this is that, so that's the starting money. Decide to depreciate it for a rate of $0.2 per kilometer. Set up equation to determine the value of car after n kilometer of use. Okay, so if we use that for n kilometer, the amount of depreciation will be n times $0.20 because the depreciation rate is 0.20 per meters over here. So the amount of kilometers that been traveled times the rate will give out the total of depreciation money. Okay, so but question A is set to determine the value of the car. So it's not asking for the depreciation. It's asking for the value of the car. So what we're going to do is we use the total value to minus the depreciation value. So that's n times 0.2. Okay, so that's the equation. And B is a use your equation from part A to determine the future value of the car after 7,500. So now we know that my n or for a equation you always have an equal sign, otherwise it's just an expression. And so you're going to write something at the other side of the car as well. So I'm going to just put value of the car. Of course, you can also say let value of the car be tn. Okay, and then you can just write 500 minus n times 0.2 equals tn. Okay, so use that equation over here and to determine the future value of if it's 7,500. 7,500 is my n value. Okay, so that's how many kilometers it has been traveled. So that's my n value over here. So what I need to do is I need to put the n value in times 0.2, and I will leave the calculation to you. No, I'll do it myself. That is 15,000. Yeah, that's 50,000 there. Oh, sorry, that's 500. 150. That's 150, and that's 2350. Now I not using a calculator, but sure, like in the exam, please use a calculator to assist you. Now geometric sequence or geometric growth. Now first let's look at the sequence over here. 1, 3, 9, 27, and 81. So I can easily see that to get 1 to 3, I times the 1 by 3 to get 3 to 9, times it by 3 to get 9 to 27, I times it by 3, and from 27 to 81, I times it by 3. So how do I get the next number is to times the previous number by 3. Or in another way, if I divide, I use the later number and then divide it by the number that's in front of it. The, the ratio of that would be 3. So 3 divided by 1 is 3. 9 divided by 3 is 3. Is 3. And 27 divided by 9 is 3 over here. So if I have Tn plus 1 divided by Tn, then I will get 3 over here. So let's look at the word written in black but in the pink text box over here. It says in a geometric sequence, the first term is referred to as A. So like what we have in arithmetic sequence, it's also indicated as 1A. So my T1 is equal to A, and the common ratio is referred as to as R. So instead of common difference, so just a reminder, the common difference is if referred as D. And how do we get it? Is Tn plus 1 minus Tn. So the later term take away from the earlier term. And how do we find out R? Is Tn plus 1 divide Tn. So instead of minus, I change it by divide. So it's still the later term divide the previous term instead of the other way around. But just instead of having minus over here for difference, for ratio we have divide. Work example. Which of the following sequence are geometric sequence, and for those sequence which are geometric, state the value of A and R. Okay, let's look at A. So the starting term is 20, so my A is equals to 20. And to get my R, I use the later term divide by the earlier term. So that's 40 divided by 20. That's term 2 divided by term 1 over here is equals to 2, which is also equals to my 80 divided by 40, my term 3 divided by term 2 here. So my common ratio for in this case is equals to 20. It is equals to 2. Let me change that. It's equals to. Okay. So that is a geometric sequence. Then my B starting term is A equals to 8, and R is the later term divided by the earlier term, which is equal to 1. So that is also a geometric sequence, and my common ratio over here is equal to 1. Now the third one, so C first term is equal to 3, and my ratio minus 9 divided by 3, that's 27 divided by minus 9 minus 81 divided by 27. So the answer here is minus 3. So that is also a geometric sequence. Now D starting term is A equals 2, and let's see if they have a common ratio over here. So later term T2 over T1, that's equals 2, and 6 divided by 4 is equals to 2/3, which is not equals to. So this is not a geometric sequence there. Okay, we're still trying to find a common equation that describing a geometric sequence over here. I'm just going to use the previous example, 1, 3, 9, 27, and 81 over here. So let's see if we can find out the generic for equation for geometric sequence is equal to that over here. So I'm still going to start with my table. My n is equals to 1, 2, I have 5 terms over here, 3, 4, 5. My Tn is 1, 3, 9, 27, 8, 81. Okay, so how do I, now I'm going to try to represent it by the previous term over here. So I'm trying to, so because I can't express anything by the first term, now, but instead I can write it as A, which is what we use to represent our equation. So I put my A over here. Um, and how do I get 3 is from A times 3. So that's A times 3. And don't forget our 3 is my R. So it's a common ratio. How do I get 9 is 3 times 3. Now the 3 here is the previous term. So that's my T2 times 3, or T2 times R. And what my T2 is A times R. So I can substitute the value of T2 by A times R. Now A times R times R, T3 is equal to T2 times R. So that's A times R times R. That's A to the power of 2. Okay. And for the fourth term, 27 is T3 times R. So T3 is equals to, oh, sorry, that's not A squared. So that's A times R squared. A times R squared. T3 is equals to A times R squared times T times R over here. So that's T3 times R, which is equal to T4. And that is equals to A times R to the power of 3, because R to the power of 2 times R is R to the power of 3. Now remember our index notation. T2 R to the square is means that I have two R's that having itself. And now R squared times R is R times R times R. So because I have three R's, that's timing itself. So I can write it in index notation. I'll write it as R to the power of 3. Okay, so similarly for my T5 is T4 times R. So that's 27 times 3, which is T4 times R. And that is equals to A to the times R to the power of 3 times R. That's A times R to the power of 4. Now, if we look back to over here, so even that is A times 3 or A times R, I can write it as A times R to the power of 1, because I only have one R that's timing itself, right? So how about the A over here? So if we want to represent by R to an index, I can write it as, first I can write it as A times 1. A times 1, 1 times any number, or you will just equals that number itself. So if I times A by 1, I'm not changing the value of the equation over here. Now, another thing is I know that any non-zero number to the power of 0 is always equals to 1. I know that my common ratio wouldn't be 0, because how do I find the common ratio? Is the later term divided by the earlier term. Unless my earlier term is 0, which it cannot be, otherwise I will just have 0, 0, 0, 0 for the geometric sequence. So my first term, or my A, is not going to be 0 in any cases, or my Tn, my previous term, will not be will not be 0 under any cases. So I'm safe to conclude that my R is not going to be 0. So if I represent it in this way, so for the first term, I actually can represent my Tn by A times R to the power of 0. Then my second term, I can represent my A times R to the power of 1. So in third term, A times R to the power of 2, A times R to the power of 3, and A times R to the power of 4. So now A, R are the things that keep repeating in my equation over here. Only thing that's changing is my 0, 1, 2, 3, and 4. And what else is changing is my term number has been changing from 1, 2, 3, 4, and 5 as well. So when my index of R over here is equal to 0, my term number is equal to 1. And when my index equals to 1, my term number is 2. When my index is 2, my term over here is 3. And when my index is 3, my term is equals 4. So the term number is always 1 larger than the index over here. So in that case, I can generalize it and write it as A times R. So that's not changing, only that is changing. And that is changing with the term number over here. So R times R to the power of n minus 1. Okay, because that's the term number is always 1 larger than the index. So to get from the term number to the index, I need to take 1 away from it. That's why it's n minus 1 over here. So now I have generalized the equation to Tn is equals to A times R to the power of n minus 1, which is the same as what they have provided for us. Now it asked me to determine the equation that represents the following geometric sequence. I'm not going to start over but from deriving the equations. I'm just going to use it. So my Tn is equal to A times R to the power of n minus 1. So I'm just going to, because Tn and my n are the two variables. N is my independent variable, Tn is my dependent variable. If you don't remember this, please refer back to the arithmetic sequence that we have gone through in the previous week. So A is my first term, R is the common ratio. That's not going to be changed. So I'm going to find out my A and my R from the provided sequence over here. Okay, so for the first one, my A, the starting term is equal to 7. So my A is equal to 7. Now I need to find out what my R is. My R is the later term divided by the earlier term. Okay, so if we use T2 and T1 as an example, so that will be 28 divided by 7, which is 4. Now if I cross-check it with T3 divided by T2, going to show you how do you do the long division here. So I have 1, 1, 2, and 28. Now I just need to see how many 28s going to the 2 over here. So first I can start with 3. So you have to do 3 over here. 3 times 8 is 24. And 3 times 2 is 6. So 6 plus the 2 here is 8. And if I do that, then I will have that's 8 over here, that's 28. So I have a remainder of 28, which means I can plus another 28 on top of it to get another set of 28 to fit into the 122. Now let's check it. So instead of the 3, I will divide that by 4. I'm going to check if I can fit 4 28s into the equation. So 4 times 8 is 32, and 4 times 2 is 8, 8 plus 3 is 11. So there's no remainder. So there are 4 28s in the equation. Then my common ratio over here is 4. Okay, so now I've got my A value and my R value over here. So what I need to do is put my A value and R value into the equation. So I'll have Tn is equals to 7 times 4 to the power of n minus 1. Okay, and B, so same. I'm going to find out my A is 8. How do I find out my R is minus 4 divided by 8? So that equals minus half. So when I ask you to determine the equation that represent the following geometric sequence, so what it's telling you is you know that it's going to be a geometric sequence. Then you don't have to check for all these terms over here. Okay, because for geometric sequence, we know that there's a common ratio between that exists among the sequence. So what I can do is I just pick 2 consecutive terms that's easy to calculate and do the calculation. Then I'm good to go. So now I've got my A and my R value. I'm not going to stop over here because it asked me to find out the equation. So I need to put my R value and A back value back into the equation that we have over here. So that is Tn is equals to A is equal to 8 times R is equals to minus half. I'm going to put a bracket over here. So my negative sign is changing with the term as well. So if I have a even if I have a even term, then my n minus 1 will be an odd number. So I'm going to have a negative sign. So for even n, I will have negative t. Let's check if for even n, so that's the second one that we have. So the second term, 2 is an even number and it's a negative term. And 4 is also an even term. And on the fourth term, we have a negative value over here. So that's how the negative sign, the index of negative number works when it comes up to our final value. Now I'm going to show you how to find out a value and r value from a given equation as Tn equals to a times r to the power of n minus 1. So if we want to find out the value of a, so for a function of a, then we need to know Tn, r, and n. And if we want to represent r, then we will have variables as Tn, n, and a in that function. Okay, so we want to rearrange the equation and put a or r on one side and Tn and n on the other side. Now, I'm just going to write the equation down here first. Now, if we want to find out a, so in the end of that, we will have something as a equals to something that in terms of t, n, r, and n. Okay, so we're going to do the same thing as how we solve a linear equation there. So because my a is on the right hand side, so I'm going to move all the other terms to the left hand side, or we want all the other sums. So we want the coefficient that's attached to a becomes 1 because the coefficient in front of the final answer there is 1. So we want to change that to 1. How do we do that? Is we can divide because it's a times r to the power of n minus 1. So what we need to do is we'll divide 1 r to the power of n minus 1. And because that we have done that to the right hand side, we need to do the same thing to the left hand side as well. Then these two terms cancel out because there's times that divide, and so it got cancelled out. So we only have a on the right hand side, and on the left hand side we have Tn divided by r to the power of n minus 1. So it matches with the equation that we've got over here, so that's correct. Now let's see how do I do r in terms of Tn and a. So I'm still going to write the equation over here. A times r to the power of n minus 1. Now this is the term that include r. So I'm going to omitted all the other terms or the coefficient as well. Now because it's r times a, so to get rid of that, I can divide the t side by a, or I can say, okay, I'm going to move a over to the other side. So by changing the sign, the operational sign that in between them. So instead of doing the times over here, so when it's moved over, it will become divide r to the power of minus n. Now, how do we so in the final answer, we want to represent it as r equals to something that will contains Tn, a, and n minus 1. Now, how do we put the n minus 1 to the other side? Or how do we get rid of the n minus 1 and change that to 1? Here is what we go to. So for in our index notation or in our index law, that we know that if we have a to the power of b, a to the power of m to the power of n, they will be a to the power of m times n because I have a I have n num I have n a to the power of m in the equation over here. Okay. Right. to make it easier, now let's think of let's make a equals to 7, m equals 2, and n equals 3. So instead of a to the power of m to the power of n, what I have is 2 to the power of 2. Oh, sorry, 7 to the power of 2 to the power of 3. So 7 to the power of 2 is 7 times 7. So that's 7 times 7 to the power of 3, which means that I'm going to repeat my 7 times 7 for 3 times. So that's 7 times 7 once, twice, and third times. 3 times. Oh, 3 times there. So now let's count. I have 7 times 7 times 7 times 7 times 7 times 7. So I have 6, 7 that's timing itself. So that's 7 to the power of 6. And it is that I have two groups of 7 sevens. Sorry, I have 7 groups of 7. That is what 7 times 7 means. Now I have what I have over here is I have 3 groups of 7 times 7. 3 groups of 7 groups of 7. Now this is a bit tricky, but if you think about that 7 squared is 2 7, and we have 3 groups of 7 squared, so we have 3 groups of 2 sevens, so make us have 6 sevens here. That's why, so we have raising an index to another index. What we need to do is time the indexes together. So that's what I've got over here. So this is what we are going to use. Now, because I'm going to change the index, so I'm going to use index law. If I have r equals to something, then what I really have is r to the power of 1 equals to something, like what I've done to the coefficient over here. So adding a 1 to the index um to the to the index of r will not change the value of the r. So I'm going to make that equals to 1. And here I'm going to use the fifth index law if I remember correctly. So anyway, it's raising a power to another power, and you can check it. That's in your should be you should learn that in year 9. And if you're not familiar with that concept, you can go back for that. But yeah, for now we're just going to take it as a granted, and we're just going to use that. So to make that equals 1, so I'm going to find out n minus 1 times which index will equals to 1. So n minus 1 times what number equals to 1. We know that any number times its reciprocal will be equals 1. Let's say 2 times half is equals 1, because my 2 over here will just go to the numerator over here. That becomes 2 on 2. And to simplify the fraction, I can just cross off the 2, because the common factor over here is itself. That becomes 1, 1, and the final answer here is 1. And same as 1001 times 1 on 1001. So I'm going to move that to the numerator over there. That's 1001 divided by 1001. So a number divided by itself will always equals 1. So I'm going to use that over here as well. So if I have n minus 1, I'm going to times 1 on n minus 1. Then my n minus 1 will just go to the numerator over here. So I have n minus 1 over n minus 1. And it's same thing divided by the same thing. So it's equal to 1. So I'm going to do is I'm going to raise the power to n minus 1, or 1 divided by n minus 1 over here. Now, because these two are the same, they are the same, they are the equal. Remember that they are equal. So if I um if I have that raise the power to n on 1 on n minus 1, and raise the power of that to 1 on n minus 1, it's not going to change the value. Like for example, if I have let's say I have 6 divided by 2 over here, and I have 3 on the other side. Now it's not going to change its value if I use 3 times 3, and I to the other side I have 6 on 2 times 6 on 2. It's not going to change the value, because I'm timing the same number over here. Alright, so what I've done here, it's the same. Doesn't matter if it's a fraction or what, because these two terms or what inside of the base over here, the base are the same. So doesn't matter what I have done to it. As long as I'm done the same thing to the left hand side and the right hand side at the same time, it's not going to change the value of it. So for that, I have r to the power of n minus 1 times 1 on minus 1. We say that we've already find out that's equals 1. So we have r to the power of 1 on one side. And on the other side of the equal sign, I have tn over a to the power of n minus 1 on n minus 1. And that matches the equation that we have got over here. Okay, now let's see this work example. So we have find the 20th term of the geometric sequence with a equals to 5 and r equals 2. So what we are going to do is we're going to substitute a equals to 5 and r equals 2 into the equation over here. If you don't remember, that's the equation for any geometric sequence. So 20th term, so T20, and we have n equals to 20, a equals to 5, and r equals to 2. So put the numbers in. That's 5 times r to the power of 19. I'm not going to solve it, but you can solve it through from the calculator. And B is a geometric sequence has the first term of 3. So first term of 3, that means a equals to 3. And 20th terms of T20 is equals to 1572864. Sounds like a phone number over there. So it's asking us to find the common ratio between consecutive terms of the sequence. So find R. So same thing, I'm going to put T n in there. So that's 1572864 equals to 3 times r to the power of 19. Okay, so what you're going to do is you go in your calculator, you can solve it through log. I'll try to see if I can divide the whole thing by 3 without a calculator. Divide by 3, that's equals to 5, 2, 4, 2, 8, 8. Okay, so that is equals to r to the power of 19. Okay, so what I've done is use 3 divided by that and keep r to the power of 19 on the right hand side. So how do you solve it is you will have your, of course you can use your log, you can use your solve function over there, but you can also do log r 524288 is equals to 19 over here, and for log we can have that's a same base. That's something you are going to learn in math method, I think. So log r equals 19. And you can find out these in your calculator, So once you find out the log r, say log r equals to a number, because the base over here is 10. So if we change the 10 over, that will be r 10 to the power of the number over here. I'm not going to do this, but you can find it in your calculator. So C, for question C, I find the first term of a geometric sequence with a common ratio of 2.5 and the fifth terms of 117.1875. So find A. When R is equal to 2.5, T5 is equals to that, and n is equal to 5. Okay, so I put in that into the equation over here. So 117.1875 equals to, of course you can put some weight. So what you need to do is put the equation in sorry. So that would be 2.5 over here. That's going to be 2.5 over here. 2.5 power of 4, and then you put your bracket of a over there. Okay, so means you solve for a. So once you have that solved in the equation, or instead you can solve it manually by a equals 117.1875 divided by 2.5 to the power of 4. So this is just calculation, and you have your calculator, so it shouldn't be a problem. Alright, so here what we have is graphs of geometric sequence. So our geometric sequence is Tn equals a times r to the power of n minus 1. So if we have a times a number over here, and because we just mentioned that our n is going to be our independent variable, and our t is our dependent variable. So basically, my n is my x and my t is my y. So when we plot them into a graph, we will have our n in your horizontal axis and my tn. So the term value is my vertical axis over here. So like what they have over here. What they have done is they discuss how the r value, how the Tn value is going to change with different region of R value that we take. So first let's see if my R is larger than 1, and remember our n or smallest n value is going to be 1. So our smallest term value is going to be 1, and my n value is just going to keep increasing to 2, 3, 4, 5, and all these natural number instead of 0. So it's always be r to the power of a positive number. Now if r is larger than 1, so if it's larger than 1, then we will have that times multiples that's larger than 1. So it will be a times r times a larger than a number that's larger than 1 over here. So this number will be larger than a, and times r, and will be a number that's larger than a times r. So it will increase exponentially because every time we are timing a number that's larger than 1. So if we times a number that's larger than 1, then the product of that will be larger than itself. So the product of the second number, so second term value, will always be larger than the first one. Okay, and if we take our number, so r here is a number that's between 0 and 1. So we are always times a number that's smaller than 1. So if a times a number that's smaller than 1, then this number over here will be smaller than our a value. And if this number times a number that's smaller than 1 again, and then that number will be smaller than the original term that we times. So for every time, the number will just be smaller than the previous term. So my T1 will be the largest. And here my Tn plus n will be the largest. Okay, now it's still the same case over here. So the corresponding one is still a decimal. So the absolute value of r is still smaller than 1. So which means the absolute value of the Tn will be smaller than 1. Okay, so that's why if we compare the difference between the dot to the axis over here, the difference is always smaller than that, and smaller than the previous one. It got smaller and smaller there. and that's the absolute value. So the distance between the dot and the axis itself is called the absolute value. Okay, so it actually matches what we described over here. So what is different is that we have a positive number, a negative number, positive, negative, positive, negative, positive. So every time I so if my r is a negative number, then my a is a positive number. So a sorry, my a times r. If a is positive and r is negative, then my a times r, which is my second term, right? Because my first term is just going to be a. My a times r, my second term, will return as a negative number because positive times negative is negative. So that's why my term 2 over here is below the horizontal line. So it lies between in the negative axis. Oh, sorry, I didn't see that there's another dot over here. So my A value is actually negative in this case. But even we don't look at this, we treat A as a positive, it's still not going to change the result of that. So I'm just going to keep doing it. Just pretend that that dot over here doesn't exist. Okay, so this is where my T1 is. That's what I'm going to do now. So for my T3 value, it's A times R times R. Okay, because if my for my T3 value, my N will be 3. N minus 1 is 2. So A times R square. R square is R times R. So that's A times R times R. A is a positive value. R is a negative value and negative value. So plus times positive times negative is negative, and then negative times negative make positive. So we can also look at that in another way. So a to the power of uh, that's a to the times r to the power of 2. So r to the power of 2, the index over here is a even number. So so if I have a negative number to the power of an even index, then the returning result will always be positive. We have gone through this in in the first couple of slides when we introducing geometric sequence. If you are unfamiliar with that, you can go back to the previous slide there. But here what we have is, so a times r that will give you positive. So that's why when we have r between -1 and 0, you will have you will show the same property as we have are lying between 0 and 1. So the absolute value of the each term, so when the number of term be increased, the absolute value of the term value will be increased. So when n increase, the absolute value of Tn will decrease. Okay, and then what we also have is if A is positive, then we will have and n is an odd number. Like 3 is an odd number, then my is Tn is even. So if my n is sorry, not Tn is even, Tn is positive. Tn will be positive. Now, if my n is a even number, like the 2 over here, my n is an even number, so my Tn is negative. Tn is negative. So similarly, if my a is negative, so we are including this point over here. If we are including this point over here, my a times my negative number times a negative number. So when in the second term, negative number times a negative number makes positive. So when my n is equal to 2, 4, 6 this kind of even number, so then my Tn value will be positive. So n even Tn positive, and if n odd, Tn negative. Okay, so now the last one. So we have r is less than -1. So the absolute value of r, or the negative of r, is equals to, is less than, it's larger than 1. Okay, so for example, -2 is smaller than 1, but the absolute value of -2, which is 2 over here, is larger than 1. And -2, so if we substitute or r equals 2 over there, -2, which is also 2, is larger than 1. So the absolute value of our Tn will increase with the decrease of r. So if r with the increase of n, so if my n got increased, so my term number got increased. So if my n is increased, with n increase, my absolute value of my Tn will increase. Because the gap between the dot and the horizontal axis has been increased. Alright, so the absolute value of my Tn is increased. Now Tn, how you read the graph is, this is if you go across it on the Tn line, so that's your Tn value over there. And if you go down to the n line, so that's your n reading of that point. And that is your Tn value over there. So that's why the distance between the number to the horizontal axis is actually your reading of your term value. Okay. Now, let's keep doing these. So, if I have my r is less than -1, it will share the property or share the feature of my r larger than 1, which is the displacement or the distance between the point to the horizontal axis will be increased. So the absolute value of Tn will be increased with the increment of my n value there. And it also will share the property of negative value. So that means if my a value, because I've done a for positive over here, so let's do a for negative in this case. If my a value is a negative number, if my a value is a negative number, for the first term, it's just going to be a, and the sign is going to be negative. And for my second term, it will be a times r. So my n is equals to, the index of r becomes 2 minus 1, which is 1. So that is a times r. Now, a is negative and r is negative. So the resulting sign, the sign of the answer is going to be positive, because negative times negative makes positive. And for my third term, is a times r times r. So that's negative times negative times negative. Negative times negative makes positive, and positive times negative makes negative. So that's negative over here. That's negative over here. Okay, wait. Yeah, all right. Okay, so because my a is negative, so I can just look at the r value, the sign of r over here. R, if it's r to the power of a even index, if it's r to the power of an even index, then the resulting sign is going to be positive. So if n is positive, if n is odd, then my n minus 1 is going to be even. Then my r to the power of n minus 1 is going to be positive. So this term over here is going to be positive. Now because my a times a is negative, so negative number times a positive number will always make negative. So that if n is negative, my Tn is negative. And if my n is even number, n is an even number, n minus 1 is going to be an odd number. A negative number to the power of an odd number is going to be negative. And also my a is negative. A negative number times a negative number makes positive number. So my Tn is going to be positive over here. So let's check it on the first term. So when n is equal to 1, which is an odd number, my Tn is negative and is below the horizontal axis over here. And my second term, when my n is equal to 2, so n is an even number over here, my Tn is positive, and my Tn value is above the horizontal line. So that's positive, that's correct. And the distance between the first point to the horizontal line and the second point to the horizontal line have been increased. So with the increasement of n, my absolute value of Tn has been increased. On the next slide, it's a summary of that in words, and then you can have a look and make sure that you can analyze it yourself when it comes to the exam. Okay, now example time. This geometric sequence is defined by Tn equals to 5 times 2 to the power of n minus 1. Now I want you to find out your a value and your r value in this case. So your a is equal to 5 and your r is equal to 2 here. Now question part A asks you to draw up a table of values showing the term number and term value for the first 5 terms of the sequence. And we have done this many times. So we have our n column over here and Tn column over here. So first 5 terms, so n will be equal to 1, 2, 3, 4, and 5. Now Tn, when n is equal to 1, that's 5 times 2 to the power of 1 minus 1. So 1 minus 1 is 0. So that's 5 times 2 to the power of 0. Any number except for 0 to the power of 0 is always equal to 1. So 5 times 1, that's 5. Now second one, put that value in, so that's 5 times 2 and to the power of 2 minus 1. 2 minus 1 is 1, so that's 5 times 2, which is 10. Okay, and you can keep substitute in the equation, but you also know that because my r value is 2, and what I can do is I just times 2 by the previous number over here. Now the previous term is 5. If I times the common ratio, then I get 10. Now the previous term is 10. If I times the common ratio 2 over here, it will be 20. So my third term is going to be 20. Fourth term is 40. Fifth term is 80. Okay, so that's done. Now plot the graph of sequence. Of course, you can plot that in your calculator, but I'm just going to plot it by hand. So you will always have your independent variable. So variables that's not depending on any other factors, which is our term number in this case, because our term number is just changing added up by 1 each time, and it's not depending on any other variables we have in the equation. So that's my n value over here, and how my Tn is changing is based on my n value. Okay, so Tn is going to be my independent variable. It goes to our vertical axis over here. I'll put the 0 over here. Normally the origin, so we have x-axis, y-axis, and my origin over here. So that's done. Now I just need to plot the graph. So when n1, so I have 5 terms, so my n is going to be equals from 5 to from 1 to 5. That's 1, 2, 3, 4, 5. Make sure when you join the graph, make sure that's evenly spread. So there's equal distance between 0 and 1, 1, 2, 2 and 3, 3, 4, 4 and 5. Okay. And also you will need to have your Tn equally scaled as well. But Tn, it doesn't have to be your y-axis. The spreading of your y-axis can not be equal to your x-axis. So it doesn't have to be 1, 1, 1, 1, 1. So you can do 5, or you can even do 10, 20, 30, 40, 50, 50, 60, 70, 80 over here. Okay, so this is what I'm going to do. Now, for when my n is equal to 1, my Tn value is equal to 5. So when n is equal to 1, my Tn value here is going to be equal to 1. So it's going to be in the middle between 0 and 10 over here. So this is my first value. That's T1. And my second value, when my n is equal to 2, my Tn value is equal to 10. So I go n equals to Tn is 10. So that's my T2. And when my n is equal to 3, my Tn is equal to 20. So I go 3, 20. That's my T3. And when my n is equal to 4, my Tn number is equal to 40. So 440. That's T4. And when it's equal to 5, that's equal to 80. So when we have a graph that's growing acceleratingly or acceleratedly, we call it we can say it's acceleratingly, or we can say this is an exponential function. Okay, so the power of the variable over here is not equals to 1, so it's not linear. Normally we call this kind of graphs exponential graph. So it could be that, it could be that. Okay, so this set of graphs are called the exponential graph. Now, like or arithmetic sequence or relation. If we want to represent the geometric sequence in a recurrence relation, then we are going to do our Tn. So we include our next predictable term value, and our starting term. Okay, so this is our next predicting term and our starting term. So these are the two elements that you need to increase when you show that there is a recurrence relation in that sequence. So that's are the key elements that you will need to show. A compound interest. Compound interest is different from simple interest. For simple interest, doesn't matter how long that we are saving. Let's say we save it for a month, so we have this amount of money been saved for a month. And if we save it for 12 months, so we have 12 times the period, then interest received in each of the period is not going to change. So the interest that I receive in 12 months is just 12 times the interest I receive in 1 month. Okay, and that's for my simple interest. For my compound interest, it's a bit different. So in the bank, you actually get rewarded if you decide that after this time frame that you're going to reinvest your money into the same account and maybe for the same period of time as well. So what they do is, so at first you are starting with the principal, so this is your R, and you're being given with amount of interest based on the interest rate. Okay, so this is your at the end of your first month, And if you decide to reinvest the money again for the same rate, for the same interest rate, so your interest will become part of your new principal. So it's going to be your P times I and times the interest rate times whatever interest rate and you have been offered. So the new interest you get for the second month. So this is your interest that you got for the first month. That this is the interest that you get for the second month. So the even the interest rate hasn't been changed, but because your principal has been changed, so it becomes your principal plus your interest that you have for the first month. So that becomes your first new principal. That becomes your new principal. So that's the principal for the second month. So time your interest rate. So that's the amount of interest you will receive in the second month. So this amount is the money that you will get in the end of the second month. And then in the third month, your money, your new interest got put inside there again. So that's your new principal, and which is your P plus your I1 plus your I2. And based on that, you will be add into, you will get another new interest over here, interest rate. So even your interest rate is not changing, but because your new principal is changed, it's been changed. So each time for each round, you have a higher interest over there. Okay, and if I represent it in terms of R, so you will have your at the end of your first term is P times your principal times R, which is your I over here. So and on the so that's at the end of your first term. So let's for first month, let's say this is your second month over here, because in your first month you only have your principal, so that's the term number here is the start of the new time frame. And what we draw over here is at the end of the time frame. So interest is always paid at the end of the time frame. Okay. Now and your third term. So in your third month, which is the end of the second period, it's the middle picture, the picture in the middle over here. So that is your the amount of money that you have got from your first term times your R. So that's your new interest and plus your principal over here. And your new principal is that. So that's plus your P plus P times R. Okay. So that's your new interest plus your new principal. Yeah. So let's say this is your principal and this is your principal times your plus your interest. This is your interest over here. Okay. And this is your new principal. So that's that P over here. This is your new principal times your rate and plus that P over there. Okay, now if you look at that, these two terms are the same. In mathematics, when we try to simplify equations, there's one thing called collecting of like terms. So these two terms are the like terms because they are exactly the same. So we can collect them by putting them aside, and because I have an R over here and I can write it as that times 1. So that time, so if I collect that, so the remaining term will plus together because the sign between these two terms is plus. So I'm going to put the plus together. So that's R plus 1. And when we are calculating that, remember our A times B plus C is equal to A times B plus A times C. So we are using that in a reverse way. My P plus P times R over here, in this case, is my A value. My R is my B, and my 1 here is my C. So if I collect the A's, what it left with me is B, the sign in the middle, and C. Okay. Now, and for my fourth term, it's going to keep repeating itself. So it will be term 3 times the interest plus the original value of t3. Now, so if we come back to our geometric sequence, don't forget that this is an example of my geometric sequence. Our starting term, which is my A, is actually P, my principal. Okay, and each times what have I times it by is I have times it by every time by 1. So if I collect the light, do the collecting of the light terms over here as well, that would be P times 1 plus R. Okay, so each time, so what I have done is I have times, so if that's 1 times R, so inside the bracket over here, they will have P times 1 plus R times R plus 1, 1 plus R. So that's 1 plus R to the power of 2. So in that case, so it will be 1 plus R, P times 1 plus R. In that case, that is going to be my new common ratio. This is my common ratio. And P times 1 plus R. And if we look at the second, at the beginning of the second month over here, now 1 times R is actually 1 times R to the power of 1. So the index over here is 1 less than, the index over here is 1 less than the term number. So that's n 1 plus R to the power of n minus 1. Okay. You can see in the printed equation over here. In the printed equation over here, it's n instead of n minus 1. The reason is that it states n is the number of compounding periods. So n is the number of compounded periods. You will receive money for the end of the periods. But because what we have done over here is starting of the period, so that's why we have 1 minus 1. And if we see it as the if we use n as end of the period, then our value or total amount of investment will be P times 1 plus R to the power of n. Okay, so that really depends on how you treat n as. So if you treat n as the start of the month, then you have n minus 1. If you treat n as the end of the period, then you will have n. Okay. I realized that the starting of the month or the ending of the month may cause confusion for some of you. And from now on, I'm going to treat my n number just for at the end of the month. So the n over here will be at end of the period. End of a period. The reason that I did start of the period is that because I want you to see the connection between principal and your value A over here. But then I realized that your principal doesn't have to be the starting of the point. So we're just going to start with the end of first month. So we're going to use my term 1 or my first term value as the end of the period. Okay, so let's try to do that in that kind of concept over here. So I have $2,000. $2,000 is my principal and compounded interest. So it tells you which equation that you have to use. In a rate of 0.5% per month. So the unit over here is per month. So P is equal to $2,000. Compounded interest. Compound interest. And a rate of 0.5% per month. They set up equation to represent Alex's situation as a geometric sequence where Tn is the amount of in Alex's account after n months. So remember our equation is Tn times equals to A times R to the power of n minus 1. Okay, so let's going to find out where we can fill out for the A and for my n minus 1 over here. So for start, if my, because like my mentioned, when we have n minus 1, that's when we are talking about start of the month. So if we want to do end of the month, we will do it differently. So you of course you can start with this method, but you will be saying we will be same similar to what we have done to, for the arithmetic sequence. So let's try something different. Let's just try to represent it by A. So the total of money. So it's still going to be in it's still talking about the amount of money in Alex's account over here, but I'm just trying to represent by a different symbol to match what I've done in the previous slide over here, to match what I've done in the previous slides over here. Okay, so let's just try to use that equation over there. But it's important for you to see the connection between the two. So my money is the total amount in the account is equal to principal times r to the times 1 plus r to the power of n over here. So if you can remember the equation there, you can just substitute the value you need in the equation. So it will be a which is your Tn equals to p principal is equal to 2000 times r is equal to 0.5%. So 0.5% plus 1 to the power of n. So that's done. But if you don't know how to do it, I will recommend. So instead of using the formula here, like what I've done for arithmetic sequence, instead of doing that, I want you to list out um, your n value and your tn value over here. And you know that for geometric sequence, once you find out the first term, you just need to times their second term by the common ratio. Now, what worth notice that is the R over here is not the rate, it's your common ratio. Okay, so don't mistaken that with the R that we have in the questions in the question. So let's keep doing our part B. If you have done that by another method, you can always cross check it to see if it matches the equation that I've got over here. And at the end of the question, so it's asking where Tn is representing a amount of Alex account after n months. So make sure that in your equation you only include Tn and n over here. So Tn will be equals to 2000 times 0.5% plus 1 n. So in the equation you only have Tn and n there. All right. Now B, use your equation from part A to determine the amount of month analysis count at the end of the first 6 months. Sorry. So find out Tn. So T6 is equals to 2000 times 0.5% plus 1 to the power of 6. Right. If you remember what I've said in the arithmetic sequence, I say even you don't know how to answer this question, you're going to put the formula there from part A over there. And if you don't know part A, because it's compounded interest, you know that's part of the geometric sequence. You're going to write something about geometric sequence over here and use the values that it has given to you in the equation and try your best to figure out the answer for that. And then whatever equation that you come up with, you're going to substitute your n value in there and trying the best you can. So you can't leave blank in any exam for any question in the exam time. All right, so that's just a matter of calculation. I'm just going to leave it to yourself. And the third question say calculate the amount in Alex's account at the end of 15th month. So make sure that it always say at the end of each. At the end of each. So you have receive your interest for 6 times in this case, and in this case you received it for 15 times. So if you have done it in this method, which n minus 1 and over here representing at the start of the month, so make sure that you have actually received your interest for the amount of time that's indicated over here. Now, because I'm just going to use this equation, which I have already represented my A in terms of the end of the month. So I'm just going to put my 15 inside. So my T15 is going to equals to 2000 times 0.5 plus 1 to the power of 15. Right. Again, solve it from your calculator. I'm not going to do the calculation there. Um, Another thing to take note is in all these questions, it asks you to find out the amount of money in Alex's account. So it's asking you to find out the total, but sometimes the question can just ask you for the interest. So make sure that you have read the question very carefully and don't make those kind of silly mistakes where that you understand the questions, but because you miss some part of it, so you couldn't get the full mark. Like the written off value, there's no difference between these and compounded interest in the calculation purpose. So instead of you have 1 plus r, you will have 1 minus r inside the bracket itself. So you will always lose a certain amount based on your new principal over there. So if you are interested, you can try to carry out the calculation yourself. I'm not going to do the proving process over here. So I've already said that your new balance for in these cases will be equals to your principal times your 1 minus r to the power of n minus 1, or to the power of n, depends on when your depreciation started. It's whether it's in the beginning of the month or it's in the end of the month. All right, now example time. Purchase for 1,250 depreciated by the reducing balance method. So reducing balance method is telling you that it is a geometric sequence. So I'll just put compounded interest over here. So that will be the negative compounded interest. So I just put compounded interest over here for short. And at a rate of 8% per annum. And so 8% per year. Set up an equation to determine the value of the hot water system after n years of use. Now, I'm going to do a table over here and just trying to show you when you don't remember the equation, this is what you need to do. Okay, so I will have my n value over here, Tn value over here, and Tn is the value of the hot water system after years. Okay, so after the first year, my n0, so in the start of the year, or just when I just bought it, my Tn number is equals to 1,250. So this is the original value, and in each year it will depreciate by 8%. So in the first year, you will depreciate, so you will get um, this amount of money less than what you worst. Okay, so this is what it got depreciated. So this is the depreciation value, and this is the original value. Original minus the part of it that's been depreciated is equals to how much that it's worth right here. So if I do the collect of like term over here, will be 1,250 times 1 minus r. So remember what I said in the previous slide. So that's going to be your principal times 1 minus your depreciate your rate over here. All right, and in the second year, um, let me just quickly calculate what that number is equals to. Looks like that it equals to 1,150. Right, because it just asks us to calculate to set up an equation I don't really need to find out what the number is, but because I want to shorten the thing that I'm going to write over here, so I'm just going to write that, and then so you know that my T1 is equal to that. But of course, you can just keep writing it over here. So my new principal in the second year will be 1150. So I use 1150 minus the depreciated value. So that's still the same. So it's still calculating by the same method. Instead of just my principal has been changed this time. And if I represent it by my 1250, which is the principal value, original principal value, then it will be my P times 1 minus R. So remember that's the first time. So P times 1 minus R minus the new principal over here, which is my T1 over here, P times 1 minus R times 8%, which is my R. Now, I'm going to do my collection of like term again. Now, the first like term is P times 1 minus R, which is the 1150 over here. So I put 1, P times 1 minus R over here, and that is just 1 times 1, the same times 1, so that times 1 minus R. So this is my A times B minus C is equal to AB minus AC. Okay, so this is what I'm using over here. Okay, now I'm going to do my collection of like terms again. I'm going to do my collection of like terms again, or I'm just going to simplify. Sorry, I'm just going to simplify the equation because I have 1 minus R or 1 minus R repeated twice. So it's P times 1 minus R twice to the power of 2. So now I have got P times 1 minus R and P times 1 minus R to the power of 2. Okay, so in the nth years, this is for my second year. So the only thing that's been changing is the index of 1 minus R. So that's the only thing that has been changed from 1 to 2. And my term value has also been changed from the first year to second year, or from 1 to 2. So it's safe to say that in nth year, my P is not going to change. 1 minus R is not going to change. Only thing that's changing is the index of that. And the index of 1 minus R is equal to the term value over here. So I can just write that equals to P times 1 minus R to the power of N. Okay, so now that's what I said in the previous slide. So instead of you have 1 plus R for money that you have been gaining by the bank or by whatever authorities, you're going to have 1 minus R because there's a depreciation in there, right? So if you know that equation over here and I ask you to find out the equation with given P and R, you just need to put P and R value in there. So you will have your Tn, but because you didn't say what Tn is representing, so at the start you might want to say that the value of hot water system is Tn, or you can just say hot value of hot water system hot water system after n years is equals to your principal. Principal is 1250 times 1 minus R. R is, don't forget that R is, 8%. So you're going to put 8% over here to the power of n. Okay, so that's the answer for part A. B is a user equation from part A to determine the future value of the water system after 6 years use. So you just put n equals to 6 into the equation. Then you have 1250 times 1 minus 8% to the power of 6. So you'll find out the value of that should be let me put the value in 757.944. Okay, and it say correct to the nearest cent. So nearest cent is over here. So I'm just going to cut the last decimal, last digit off. So that's equals to that. All right, and you can always check your value because of the depreciation, your value is always going to be smaller than the 1,250, and because you know that it can't be a too much less than the original value. Think about the stuff that people selling on Gumtree. The old product will be cheaper than the new one, but you won't be given out for free. So if you have a number that's um really low, then you know that your answer is going to be wrong. And also when you put in your calculator, be flexible. Like the 1 minus 8% over here. Of course, you can do bracket and do 1 minus 8% to the power of 6, but that's a lot of trouble. And some of you might forget how to do the how to like to do the bracket over here. I know that you know how to do it, but you may forget to do it when in exams or what. But you always know that because you're both math, you always know that you need to solve out the brackets first. So in the calculator, I will recommend you to do 1,250 times 92%, or even I know that 92% is equal to 0.92, so I'll just put 0.92 in my calculator over there. So that's much less thing to buttons to press compared to the equation over here. All right, so just be smart with your calculator operation. Right. So this example actually will fit into earlier slide, but you might see that in the right position, but yeah, it may just come out with how it's going to be. So first let's see that this question is asking us to start a recurrence relations. Do we still remember what we need to say when uh, it talks about recurrence relation. So for recurrence relation, it's important that we stated that there is a recurrence and there's a relation. So how do we do that is we're going to state the first term. So we're going to tell them what the first term equals to, and what we're going to tell them what's the next possible term that could be equals to. Okay, so we'll tell them the starting one and also the tn plus 1 based on our t1 value over here. N and R. Sorry, because this is a geometric sequence, so we'll use R. And B, use your relation from part A to estimate the height of the 4th and 5 ribbons. Give your answer to correct decimal place. Okay, so now, so I need to put in my number when my n equals to 4 and my n equals to 5. And I need to change my answer to decimal places. See, sketch the graphs and against the height of each band. So yeah, I'm just going to do that later after we calculate some of them. And of course, you can switch to calculator at any time, but because I think that's really easy to do, so I'm just going to show you how to calculate it by hand. Alright, now, so we have figured out what the questions want us to do. So in a really worded question like this, you will want to find out what the answer is. Otherwise, you will just be overwhelmed by all these vocabularies over here. But if you look at the answer, it's actually really easy and really straightforward, that what they tell us really clearly that what they want us to do and what they want us to find out. So after we read that, so I know what are the informations that I need to find from the question. So with that purpose, um I'm just going to remember my purpose when I'm going to read the questions. Now I say a tennis ball must meet certain bounce regulation. Okay, from a height of 254, so that's where it's dropping from. So from where it's dropping from to the ground is 254. Okay, and then to bounce the rebound height, that must rebound to 1035, sorry, 135 to 147 height. That's over half of the original distance. Okay. Yeah. Right. And Jenny decided to test the ball runs theory out. She dropped a ball from a height of 200 meters. So if you are dropping from 250, so you going from 147 to 135. She dropped a ball from a 200-meter side, so 200 meters. She found that it bounced back to 108. So 108, that's your first time. That's bounce of the first time. Where is my pen? Here. So that's 108. I call this T note T1. This is the first rebound. The second one is T2, and that equals 58.32. And the third one is T3 is 31.49. Okay, so after I draw out the thing, I find out the first paragraph is completely useless. Okay, so that part over here is completely useless. We don't need that. We just need that to do the questions. Now, if we cut this out, then these questions looks much more doable. Alright. So I've also got my T note T1, T2, T3 over here. Now, given that we know this is going to be a geometric sequence, would that be compounded interest, or would it be what we have over here, reducing balance? So is that my R is going to be positive or my R is going to be negative? Now, because my uh, larger term, my second term is smaller than first term. So I can conclude that my common ratio, my 58.32 divided by 108 is going to be a number that's less than 1. Okay, so if you look at it as 1 minus my r, so the number over here, the sign that in front of the r is going to be negative. Alright, but we don't know if it matches or compounded interest thing over here. So let's just hold the thought and just try to solve it out by our T1, T2, and T3 there. So for set up a recurrence relations, we know what my T1 is need to be equals to. T1 is equals to is my T1 is the height after first rebound. So my T1 is equal to 108. How do I calculate my next term? Is my first term times the ratio. Okay, how do I find out the common ratio? It's the second term divided by the first term. So if we do 58.38 is 40.32 divided by 108, and that's equal to 0.54. So I'm just going to write my answer for part A over here. So T1 is equal to 108, and my Tn plus 1 is equals to 100. No, sorry, not 108. It should be Tn over here. So it's going to be Tn over here. Tn times R. R is 0.54. Now I'm going to check it by divide 31.49 to 58.32. See if there's a match. And so I've done the calculation that's equal to 0.539952. that's close enough to 0.54 over here. So I'm just going to keep that. And B, it says use your relation from part A to estimate the height of the fourth and fifth term ribbons. So I'm going to use, no, I can't use my Tn is equals to ARN minus 1 because um the centimeter or the height over here is measured, like what I find for the ratio, it's not exactly 0.54 over here. So they have rounded out some value during measurement. So I can't find out the exact value. That's why they say estimate. So how do I estimate? It's based on the number that's been given to me. So I'm going to use the third ribbons. So if I want to find T4, then my n is equal to 3. So I'm going to use the T3 value over here. T3 is equal to, oh, sorry, that's 54. T3 is equal to 31.49 times 0.54. And that is going to give me 31.49 times 0.54. The answer is 17.0046. Now, because look at the question asks us to leave two decimal places. So we look at the third decimal places over here, and that's 4. 4 is less than 5. So we just going to round it down. And I'm going to, even though that's 17.00, I can't write it as 17 because it asked me to keep two decimal places. So the zeros are there to hold the decimal places. Now the fifth one, so I'm going to use that to calculate my fifth one. So my T5 is equals to T4, which is 17.00 times 0.54. The answer is 9.18248. And oh, that's the number shown on my calculator. So if you choose less decimal numbers, you might show a different value. So round it up to two decimal places. Look at the third one is 2, so I'm going to round it up. The number is 9.18. And remember to include your unit over here, centimeter. Now sketch the graph. So sketch the graph, we're going to do, and of course you can do that by calculator, your n and your tn. I'm just going to put tn over here. So when n is equal to 1, your tn is equal to 180. 108. And when your n is equals to 2, your t value over here is 58.32. And your t3 is 31.4149. And that is 17.00. And that's going to be your 9.18. It's not drawn to scale, so when you draw it, you better draw it to scale. But in the exam, it's very unlikely they ask you these kind of questions when they ask you to draw it by yourself in the general math examination. But that's definitely something that you will be expected for mathematics. And in the real exam, you'll given grid paper, so you don't have to really worry about straight lines and etc. But it will be tricky to um, to put down the scale that's best for your interest. Now, my suggestion will be you always start with 10 or 5 included in there. So you don't have to use up the whole paper. In the exam, you're given a A4 um, grid paper over here, but you don't have to use all of it. So you don't have to spread your graph for the entire pages. You can just use a small part of it and make it 10 over here and make it, let's say, changes every 10. So maybe each 5 grid will represent 10. So each small squares over here will represent by a 2. And here you can do, let's say, one small square represent by 1. So you could do actually 5, you do 5, 10, 15, 20. And you'll understand that when you really comes to that kind of question over there. For today, we're just going to pause it over here.